Good morning. I'm Katherine Hambleton from NASA's Office of Communications. We are here at the U.S. Army Proving Ground in Yuma, Arizona, and for the final test of the Orion parachute system. We've got plenty of room out here in the expanse of the Arizona desert to see the parachutes, 11 parachutes in this system in action. And these tests will help us ensure that we can bring astronauts home safely when we send crews out to the moon and beyond. About an hour ago, the C-17 took off carrying the Orion for today's test. It flew up about 6.5 miles overhead, and we've seen it pass. Everything is tracking towards a drop test at about 8 o'clock this morning. Here with us is Mark Kurasich.
Hi, Catherine.
He is the Orion Program Manager, and he is responsible for the design, development, testing, and manufacturing of the Orion spacecraft. Thank you for joining us, and congrats on getting to the final test.
Well, thank you, Catherine.
Please tell us what we're going to see today and why it's important.
All right. Well, I think most of you know that Orion is our new human exploration spacecraft, and this is the spacecraft that is going to take people farther into space than we've ever gone before. And our missions will last for several weeks long, and during that time, the crew will travel hundreds of thousands of miles into space and back in some of the harshest environments that people have ever been exposed to. Extreme thermal, extreme radiation, and so on. As incredible as all that may be, one of the most challenging parts of the mission is what we call the entry, descent, and landing phase, when we slow the spacecraft down, and we have to do it just right. So when the capsule touches down into the ocean, it's going slowly, not to protect the crew. And that's what brings us here to the Yuma Proving Ground. The system that does this for us is our Orion parachute system. We call it the CPAS system. And that's what we're going to be doing here today. We're going to be conducting our final test of this system here on the ground before we test it in coming back from space.
This is a big deal. Can you tell us what the team has gone through to get to this point?
Oh, yes. We've had an incredibly talented engineering team at the design of the system for over a decade, over 10 years. And over this period, they've actually conducted well over 40 drop tests. And throughout this period, they've made observations. They look at the parachutes every time they land. And from all these observations, they've made countless improvements to the design, to how we manufacture the parachutes, to how we install the parachutes in the spacecraft, to make sure all of the lines are laid out exactly right, so as the parachutes are pulled out, nothing gets caught up. And the team's done a fantastic job. This last series of tests, the qualification tests, what we do is we push the parachute system to all of the corners of the operational box where we expect it to operate. And we intentionally induce failures. We intentionally say, on today we're not going to deploy a particular parachute, to validate the system works exactly as it is supposed to under the most extreme environmental conditions and with system failures.
Thanks, Mark. Now, this is the only system on Orion that has to assemble itself mid-air, which makes it a particularly challenging job for the engineers that have to design and develop it. Let's take a look at some of the preparation that earlier this week, including loading the capsule and the parachutes into the airplane and making sure that everything is rigged. This work is all in preparation for the first crewed mission that will send astronauts around the moon and beyond, launching on the Space Launch System rocket. We already have the parachutes for the first uncrewed mission packed into Orion and ready to go for the first flight. Next with us, we have astronaut Randy Bresnik.
Randy, thanks for joining us out here today on this beautiful day.
Thank you, Mark.
Thank you, Mark.
Catherine.
Hi, Randy. Thank you for joining us.
Good morning.
Can you tell us what it's like to watch a test like this, knowing that your fellow astronauts or you could possibly be on one of the Orion flights in the future?
Well, I know that I and certainly all of my fellow astronauts and hopefully future astronauts are very excited about this test because it is that culmination of this decade-long of testing of such a critical system. The fact that it's the final test that we have developed the system, reduced weight, increased safety, and we are, getting to the point where after today, everything goes according to plan, we're ready for flight. That is just astounding. And certainly, when I say critical system, the crew will have survived the launch, the passage through the radiation belts, 3 days, 250,000 miles to go around the moon, and 3 days, 250,000 miles to come back, in through the Earth's atmosphere, Mach 32. They survive all that. The one thing they're looking for is that tug of the parachutes when they come out, and then they know that they are safely going to be able to land back on Earth after that mission. So we are very excited that today's test is the final one and qualify Orion for flight.
Great. So what are you looking forward to seeing in today's test?
I'm looking forward to counting to the number 11. That's the number of parachutes that are going to come out on the different series of the sequences of the drop. And I also look forward to seeing the point where I'm told from the testers that when it comes out of the C-17, it has a whole system and a pallet that Orion's riding on. Well, the Orion then departs from that pallet and all the parachutes are off, and it falls for 12 seconds before the Orion system that we're actually testing, the 11 parachutes, starts operating. So I'm looking to see if all these people who know this test and this system are holding their breath during those 12 seconds, and we get a collective, gasp of relief when the forward bay cover 3 parachutes start coming out, initiating the sequence.
Great. So 11 parachutes in 12 seconds. We'll be counting with you.
All right.
All right. Thanks. We'll let you go watch the test now.
All right. Thank you.
Thank you. All right, we're a few minutes away, and I believe the C-17 is about ready to drop the capsule from its cargo bay. Up next, we have Jared Dahm, and he's here to walk us through the test and give us the play-by-play as the parachutes unfurl, and he's also going to answer a couple questions for us from folks online. If you are watching online, please use the hashtag #AskNASA to submit your questions. All right, Jared, so what do we expect to see a few minutes from now?
Okay, so the main point of this test is to see how the 11 Orion parachutes perform. But in order to get to those 11 parachutes, we have over 10 support parachutes to get us to the test point. So not only do we see those 11, but another 10 getting us there.
So 21 total?
21 total.
Okay.
So the first thing you're going to see is our tow chute. So that tow chute comes out and it'll be attached to the aircraft for a good 10 seconds before it pulls out our 2 extraction parachutes. Those 2 extraction parachutes are about 28 feet in diameter, and their job is to pull the test vehicle on the pallet out of the aircraft. As the pallet is getting extracted from the aircraft, it'll pitch down. The capsule will release from the pallet, and we'll deploy 2 programmer parachutes. Now these 2 programmer parachutes will get us set up to the right test point to begin our free fall that Randy described. We'll free fall for about 12 seconds to gather up that speed to get to a high, what we call dynamic pressure, to really test the parachutes on the forward bay cover. That starts the real test. Now our 3 forward bay cover parachutes will be mortared out of the cover, followed by 2 drogue parachutes, 3 pilots, and 3 mains. So I'll give you the play-by-play as everything's coming out.
Sounds great. And what specifically are you testing on this drop, and how does it help certify the parachutes to carry humans?
Excellent question. So this is the final qualification drop, and this is a full system. So we're testing all of our parachutes. As Randy described, we test various failure scenarios where sometimes we don't deploy an FPCP or we don't deploy a main. This will have all 11 parachutes, and we're looking for an orderly deployment of those parachutes, meaning the components come out when we expect them to come out. We'll also look at the chutes after we recover them. So the test doesn't end after touchdown. We'll recover the parachutes, inspect all 11, look for any damages that are unexpected. We do expect some damage landing out here in the desert. We got some prickly bushes, but we are looking for any flight damage that might be of concern.
All right. Now we're going to take a couple questions from folks watching on NASA TV. Again, if you'd like to submit your question, please use the hashtag #AskNASA. All right, let's see what we've got here. Under normal conditions, what is the deployment altitude for each parachute type?
Excellent question. So Orion, it re-enters the atmosphere at about 17,500 miles an hour and uses the heat shield, basically the drag on the blunt body of the spacecraft, to slow down to about 350 miles per hour at about 25,000 feet. At about 25,000 feet, we begin the sequence of deploying the forward bay cover parachutes to release the cover, followed by the drogue parachutes immediately after. We'll ride those drogue parachutes down to about 6,000 feet above the Pacific Ocean, and at 6,000 feet, cut away those drogue parachutes and immediately deploy our pilot parachutes, which pull out our mains, which take us down to 0 feet.
Okay. And what materials are used for the chutes?
Excellent question. So we use a combination of materials, mostly Kevlar and nylon. So everybody's heard of Kevlar, kind of using bulletproof vests. It's very tenacious, very strong for a relatively lightweight. We use that Kevlar for our load-bearing members. We call them our radials, our suspension lines, our risers. And then the drag-producing members, we use materials like nylon, which are very lightweight, very thin. You can actually see through the broadcloth on our orange and white mains. And those produce the drag that gets transferred down to the spacecraft.
All right, and how much has technology for parachutes changed over the years?
Excellent question. It's changed quite a bit, a lot in the material properties. Apollo used steel risers, which are very heavy, very bulky, hard to pack into the spacecraft. We've been able to transition to Kevlar risers now that we have Kevlar available. So that saves weight. It makes the packing, the integration a lot easier. We also have a lot better computer simulation techniques to help us both here out on the drop zone and to simulate what's going to happen with the actual spacecraft so that we can get to the final design solution with fewer drop tests.
All right. And how heavy is the Orion crew capsule that the parachutes are bringing down?
Orion's about 21,000 pounds. So that's a lot of metal, a lot of systems in there, including our humans, and the humans are the most important part. Looks like we got about a minute until we have our extraction.
All right. Do you think we'll be able to spot the plane?
Yes, so we've got some folks helping us. They'll be coming in over here from the east, right about where the sun is, so just be careful not to look directly into it.
All right, let's see if we can get a shot on the plane. All right, I can actually hear one of the planes.
Yep, that's actually one of our support helicopters. So we have various aircraft at different altitudes. Video and imagery is very important for us on these tests. So we have aircraft staged at various altitudes to get the right sequence of video and photos. You can see we have one chase aircraft there. Okay, there's our tow chute. So our tow chute is out. It's held on, anchored to the aircraft right now. In a moment, the crew will release, and it will pull out our 2 extraction chutes. And there go our 2 extraction chutes about to pull out the pallet. There's the pallet with separation on the PTV right there. Now we have static line deployed 2 programmers. Now those 2 programmers will stabilize the vehicle and get us to the right altitude, attitude, and velocity for us to begin the test. The test will begin with severing those programmers for that 12-second free fall. Now the vehicle is unstable at these speeds. So we have software on board that will monitor the rates and the attitudes of the vehicle to make sure that we don't tumble forward. We don't want to tumble the vehicle. That would be bad for our drogues to be deployed at apex forward. So our software will monitor there's our free fall. So if you want, you can count to 12. Looks pretty stable. That's looking great. You will soon see the 2 drogues, or excuse me, 3 forward bay covers. There they go. They lift off the cover separated, 2 mortar deployed drogues. You can see lots of debris in the air. Those are the lids, the bags, other equipment. So now we're riding these 2 drogues. They are reefed. That means that we have a line wrapped around the skirt of the parachute, constricting the diameter of the chutes to modulate our drag area, to reduce our loads, and to kind of help with an orderly inflation. So now we're going to ride these drogues down to as low as we possibly can. The actual Orion vehicle with our astronauts in it will descend to the ocean, which is at 0 feet mean sea level. Here at There's the 3 pilots, 3 mains. Now these will inflate through reefing stages similar to the drogues. It's more pronounced on these mains, so you can see a light bulb shape there in the 3 mains. This is looking really good so far. Now we're into the second stage. They're a little bigger, and if you listen closely, you can hear those mains inflating, and there we go to the full open. Beautiful shot right there. 3 mains spread out. You can hear the crowd in the back cheering. We're not quite done yet. There's still a lot of stuff in the air. But here you can see the 3 mains bouncing in and out. That's completely expected. You can see there's holes in the sides of the parachutes. We put those there. They're supposed to be there. We call that geometric porosity. That does reduce the drag of the parachutes, but it does increase the stability. So the increased stability makes those flyouts smaller than they normally would be, which means that on average, our drag is higher. So one of these 3 main parachutes was actually what we call environmentally tested. So we put one of these parachutes through the entire sequence that a flight parachute would see. This includes what we call creep testing, thermal cycling between high and low temperatures, vibration testing, and rapid depressurization testing. We did all that throughout this calendar year and then integrated it directly onto this vehicle to validate the design to ensure that it can go through those environments without having any issues. So we've seen the 11 Orion parachutes, and there's also the handful of test support parachutes. There is one parachute descending the pallet to the ground. Now this is a special parachute. It is very similar to our Orion mains, but the lower sails, I'm not sure if the camera's on it, but it's got a lighter weight broadcloth. Oh, there we go, we've got touchdown. So Orion looks like the test vehicle is upright, so that's great, that makes recovery easy. A lot of times it will flip over. It's not designed to land here in the desert, so when it hits the hard ground versus the water, it kind of rolls around a little bit, but that's not a big deal. You can see those orange chutes deflating and falling to the ground. The ground winds are very important during this testing in terms of safety for the personnel that go out to recover the chutes. You can see one of those main parachutes is still a little bit inflated, but that will droop down as the mouth of it kind of closes up. So the safety of the crew and safety of the personnel is very important in the recovery. If those parachutes are inflated, they generate tens of thousands of pounds of force, and that could be very dangerous to anybody going out to recover them.
All right, and so what's next?
So next is the recovery process. So this was the hard part. Next is also the hard part, I guess. So we'll drive out there and we'll go recover each of these parachutes, all of the other equipment, bag them up and take them to our shakeout tower. At the shakeout tower, we'll string them up, shake out all the sticks and scorpions, and look at any damage that we may have incurred.
Okay, and so Jared, all right, I can imagine that, no 2 days the weather conditions are exactly alike. So how do you design a parachute system for all the conditions that we could possibly experience when coming home?
Excellent question. So it's not so much the weather that Orion has to worry about, but it's the entry conditions. So we have to design the parachutes to perform well in everything from an abort scenario to a nominal entry. So a nominal entry is up at 25,000 feet, 350 miles an hour, whereas an abort could be from the pad, and we need those parachutes to work very quickly to get the crew to a safe speed before we hit the water. So it's a lot of testing here, testing all those various scenarios to ensure that we have the data to inform our computer models, which will tell us that the parachutes are safe.
Great. Well, congratulations for completing the test series to qualify Orion's parachutes to carry humans.
Thank you very much.
All right. Well, thanks, Jared, for talking us through the questions and answering our questions and talking us through the test.
You're welcome.
And thanks to everyone that joined us on NASA television. This test completes the parachute testing to get ready for crewed missions. And together, Orion and the Space Launch System rocket will be the backbone capabilities that will carry humans to the moon and extend human presence into the solar system farther than ever before. If you'd like to follow along with the progress we're making on the Orion spacecraft, Please visit nasa.gov/Orion.
Subscribe for more space.